Hello and welcome to my YouTube channel. Our topic today is sequences and series. We'll start by definition. A sequence is a set of numbers written in a definite order such that each term of the sequence can be determined by a specific formula or rule. Examples of sequences include un equal to 5 minus 2n or un equal to 2n squared plus 1. So this is how we represent sequences, where each number is called a term of the sequence and is denoted by u1, u2 and so on. So anywhere I have n, I can actually replace it with 1, with 2, with 3 and so on. Then u1 is the first term, u2 the second term, and un, let's call it the nth term. The nth term of the sequence is generally called the general term of the sequence. A sequence can be finite or infinite. When a sequence is finite, it means we know what the first and the last terms are. But when it is infinite, it means the terms are continued indefinitely. Arithmetic progression AP. By definition, this is a sequence in which the difference between any two consecutive terms is constant. It is defined by its first term denoted by A and common difference by D. The general arithmetic sequence of a sequence is written as un equal to A plus n minus 1 times D. Let's look at some examples here. The 7th term of an AP is 27 and the 12th term is 47. What is the sequence? You should recall that the 7th term is 27 and the 12th term is 47, and the formula we need is un equal to A plus n minus 1D. Now, you are going to write them out as a simultaneous equation, u7 and u12, and you are going to arrive at equation 1 and equation 2. Equation 1 is A plus 6D equal to 27, while equation 2 is A plus 11D equal to 47. Now, when you solve the problem simultaneously, you are going to get that the common difference is 4. And the first term A will be 3. When you do your substitutions carefully, that's what you're going to have. Now, having gotten that, you can now substitute the value A and D into the general term of the sequence, and you're going to get un equal to 4n minus 1. That is the general term of the sequence. So when n is 1, you have 3. When n is 2, you have 7. When n is 3, you have 11. When n is 4, you have 15, and the sequence continues. So 3, 7, 11, 15, and so on. Now let's look at a geometric progression. This is a sequence in which the ratio of any pair of consecutive terms is constant. It is determined by its first term A and common ratio R. The general geometric progression of a geometric progression is un equal to A r raised to the power n minus 1. That is how we describe the nth term of a GP. Let's look at some examples and see how we can apply these things. The second term of a GP is 8 over 9 and the sixth term is 9 over 2. Find the GP. Again, we are going to handle it like a simultaneous equation. The second term is 8 over 9, that is u2, and u6 is 9 over 2. Dividing equation 4 by equation 3, you are going to get it 1 over 16. Therefore, finding R, raised to the power of 4 will be 81 over 16, and r will be the fourth root of 81 over 16, which will give us plus or minus 3 over 2. Now, using equation 3 to solve for r, we have two values for r. The first one is r will be plus 3 over 2, while the second one is r is minus 3 over 2, implying that we have two GPs. Using equation 3 again, to solve for a, when you substitute r to be 3 over 2 and ar will be 8 over 9, we have this expression, and a, which is the first term, will be 16 over 27. But when you substitute r equal to minus 3 over 2 and ar equal to 8 over 9, we are going to have that a is minus 16 over 27. So the resulting GPs are, we have for a equal to 16 over 27 and r equal to 3 over 2. In that case, the sequence will be 16 over 27, 8 over 9, 4 over 3, 2, and so on. But for the case where a is minus 16 over 27 and r is minus 3 over 2, the sequence is going to be minus 16 over 27, 8 over 9, minus 4 over 3, 2, and so on. Let's look at some of an arithmetic progression AP. For an AP, the sum of the first term any terms are, the formula there is Sn equal to n over 2 in bracket 2a plus n minus 1d, where a is the first term, d is the common difference. Let's look at this example. How many terms of the AP 3, 7, 11, and so on must be added together to give a total of 300? This is the solution. Here, the first term is 3, the common difference is 4. What we are looking at is the total of 300. Then, what we are looking for is now n. So when you substitute this information into the formula, which is n over 2 in bracket 2a plus n minus 1d, you are going to have 300 equal to n plus 2n squared when you do the proper substitution and simplification. At this point, you now solve for n. It's going to give you something it's going to give you a quadratic equation, which you can either use factorization method or any other method of your choice to sort it out. In this case, since it's a quadratic equation, you are going to have two values of n. The first value of n we have is minus 25 over 2, while the second value of n is 12. But for this particular problem, we are going to choose 12 because the number of terms required must be a positive integer. So n will be 12. It's 12 terms of the sequence that you need for the sum of the sequence to be 300. Let's look at some of a geometric progression. The sum of the terms of a geometric sequence form a geometric series. The sum of the first n terms is given by Sn equal to a plus ar square, and so on. Now the general formula is given below. When r is less than 1, that is when the common ratio is less than 1, then you can use the first formula there. When the common ratio is greater than 1, you can use the second formula. Then when you are asked to sum to infinity for a common ratio that is less than 1, then you use the third formula. Let's look at this example. The sum of systems of a GP is 2730 with common ratio 4. Find the first term of the GP. Here, the sum is 2730. The common ratio is 4. N is 6, then what is A? Since our R is greater than 1, then we are going to choose this formula, which says Sn equal to A in bracket r raised to the power n minus 1 all over r minus 1. So 2730 will be equal to what we have on the right hand side. Therefore, after proper simplification, the first term A is going to be 2. Thank you for watching.